All right, here we go. We're talking about 1.3. In the Math 3 book, they keep both of those sections together. This is 1.3, but the last method that we're learning is called elimination. I've got some steps over here, and they're kind of vague, so we'll talk about look to see what's canceled or do anything that you can. And so I'll kind of elaborate on these steps, but you've got 7 steps to do elimination. Let's look at the first example. X minus y is equal to 1. And then x plus y is equal to 3. Okay? So, first step is stack. Okay? And when it says stack, that means get all your x's lined up, get your y's lined up, and get your numbers lined up. Remember when we did substitution, we had something over here and something over here. Remember, this one was going in that one, and then that one was going in this one, and we had them side by side. In elimination, we don't want to do that. We want them stacked like this. X's over x's, y's over y's, numbers over numbers. Okay, and it always equals a number on that side. Step number 2, look to see what can cancel. In this very easy example, you can immediately see that the y's are set up to be canceled. If I were to add these two equations up and add everything up, the y's would be eliminated. Okay, this method is elimination. So we look to see what would cancel, or we look to see what would be eliminated. 2x is equal to 4. X plus x is 2x. 1 plus 3 is 4. So immediately almost, what is x equal? 2. Okay, that's why elimination is the best method. So the step number 3 right here where it says do anything we need to do, on this one we didn't have to do that. They were already set up. We had negative y and positive y. They were already set up to be eliminated. Okay, so we didn't have to do anything on this one. The next example we will. All right. Number 4 says cancel. That's what we did. Step number 5 is add. That's what we did there. And then solve. Okay. Step number 7 is plug it in because we only have half the answer. Right? If we were to graph this, the two lines would intercept at 2 something. So we have to find out the y coordinate of the equation. So we take this and we plug it in. Doesn't matter where we plug it in. We could plug it in there or we could plug it in there. Which do you think is easier, to plug it in the top equation or the bottom equation on this example? The bottom one's easier. Why? Because y is positive, and that's what we're trying to find. We won't have to divide by a negative. So it doesn't matter. You could do it in the top and still get the right answer. But if we do it in this one, we get 2 plus y is equal to 3, and obviously y equals 1. So our answer, guys, is 2, 1. If we were to graph the two lines, they would intercept at 2, 1. Okay? And look something like that. Questions? What method is this? Elimination. We are eliminating one of the variables. Doesn't matter which one, it's whichever one is set up for us to eliminate. Okay, questions? I want to move on to a harder example. Anybody have a question? All right. How would it be a harder example? What could I do to make it harder? Instead of negative y and positive y, what could I do to make it a little harder? We're going to have to do something, right? It's not going to be just set up for us, ready to go, ready to eliminate. Let's do this one. X plus 4y is equal to 11. And x minus 6y is equal to 11. X plus 4y is equal to 11. X minus 6y is equal to 11. Does anything cancel as is? Right? So we stacked them. We looked to see if anything cancels. Does anything cancel? If I were to add up these two equations, would anything cancel? No, because I got x and x. That gives me 2x. It doesn't cancel. So step number 3 is do anything that I can to get it to cancel. Okay? And sometimes that varies. That's why that's kind of vague. Most of the time, what do? We're going to multiply through by something. If I take this equation and I multiply through by negative 1, right, everywhere, all 3 things, and I distribute it here and here, here, and here, I'm going to rewrite it. X plus 4y is equal to 11. If I distribute negative 1, I'll now have negative x plus 6y is equal to negative 11. Now does anything cancel? The x's cancel. So in this problem, it was necessary for me to multiply through by a negative 1. Why is it algebraically okay to multiply through by a negative 1? Why is that okay? I can't just randomly multiply by negative 1. Say it again. Clay, why is it okay?
I had a question.
All right, just let me finish my thought, and then you can ask your question. It's only okay to multiply through by negative 1 if I do it to all three things. Right? If I've got x equals 2, I can multiply everything by 2 and get 2x is equal to 4 as long as I do it to both sides. I haven't changed the integrity of the equation. Okay, so as long as you do it by all three things, you're okay. Alright, so now we've said that our x's, right, step number 4 is cancel. Our x's are set up to cancel. They cancel. I get 10y is equal to 0. Some people want to put no solution. Is that no solution? Is that a false statement? Do we have an answer for what y equals when 10y is equal to 0? Y equals 0. The only thing in the universe I can multiply by 10 and get 0 is 0. Right? I divide both sides by 0. Y equals 0. Alright, so that's half my answer. I know that 0 goes right there. How do I find x? What's step number 7? Plug it in to find the other variable. Doesn't matter which one. Plug it in somewhere. I would recommend you plug it in right there, because what's 4 times 0? 0, and what do you have left? X equals what? 11. X equals 11. Could you check that answer? Yeah, go back to the original problem, plug it in both equations, and see if it works. Clay?
So, when you started this problem, why couldn't you have just taken the 4y and like added the 6y and made it negative 2y equals 22?
It wouldn't have canceled. The whole idea is to get something to eliminate. When these eliminate, all I'm down to is just a y. If I were to try to eliminate these and got negative 2y, the x's would still be there. I wouldn't be any better off. The whole goal is to get one of the variables to eliminate. Nod your head if that makes sense. Okay, good. Let's do another. What's the first step? Stack. Stack it up. Alright, let's alright, here we go. 5x plus 3y is equal to negative 10. And 3x plus 5y is equal to negative 6. This is as hard as I can make it. Why is this one hard as I can make it? Why is it difficult?
Because they're reversed.
Well, right, because I can't just multiply this one by 2 or multiply this one by negative 3. I can't. One is not a multiple of the other. Does everybody understand that? If this was 6, then what could I do? I could multiply this one through by what?
2.
By negative 2, and then they'd cancel. But it's not 6, it's 5. So how can I get 3 and 5 to cancel? Multiply both of them. I have to multiply both equations by something. Okay, and it's your choice which variable do you want to eliminate. Do you want to eliminate the x's or the y's? Let's eliminate the x's. So I'm going to multiply this one by 3. That'll make that 15x. I'll multiply the bottom one by what? Negative 5. Why negative?
So they can cancel.
So they can cancel. One of them's got to be positive and one of them's got to be negative. This is as hard as it gets. When you have to multiply both equations by something, that's as hard as it gets. So I distribute here, here, and here. I'm going to write it underneath here. I get 15x plus 9y is equal to negative 30. On the bottom, I distribute all three places. How important is it to do all three places? Extremely. You will not get the problem right if you don't do all three places. Negative 15x minus 25y is equal to positive 30. Hold on. Oh, there it is. Yeah, we get 0 again. That's no big deal. What?
So could you cancel 30 each other?
Yeah, they cancel and this cancels, and I get negative 16y is equal to 0, or y equals 0. No big deal. Same thing. Plug in the 0, and what do I get? Take this 0, and plug it in right there, all of that becomes 0. 5x is equal to negative 10. What is x equal?
-2.
Negative 2. Does it matter where you plug it in? I would suggest that you go back and plug it into the original equations. One out of the two original equations. Okay?
I mean, can you do it to the 15?
You can, as long as you've done everything correct, you'll get it right. But I would suggest to go back up here because typically this is a more simple equation than these two. Okay? Can I erase this? Anybody still right? Alright. Got one more for you. I'm going to let you do it on your own, and then if you do it, then we'll move on and do some practice. Let's try this one. 7x plus 4y is equal to negative 4, and 5x plus 8y is equal to 28. Try this one at your desk. What method are we using? Elimination. Peyton, what variable are you going to eliminate? Y. Would it be okay if someone didn't see that y eliminated and they eliminated x?
Yes.
It would be okay. You would still get the answer right. It just would take long. Try this one now at your desk. We've already said you're going to eliminate y. All right, here we go. George Hill, tell me what my first step is going to be.
Stack it.
All right, good. We stack it. X and X, Y, Y, number. Step 2.
Cancel it.
All right, we can't cancel yet. Nothing cancels. What do we? So we look to see what anything, do anything. All right. So what are we going to do?
Times the top.
Top equation by what?
-2.
Very good. We put parentheses around the whole thing. We put a -2 right here. Tell me what to write right here, George. I'm going to rewrite this one right here. Make it easy.
-14x
Good.
plus -8.
8y. Good.
Equals 8.
Very good. Exactly right. We add them up. These cancel. I get -9x is equal to 36. Is that right? So x equals what?
-4.
-4. Thank you for playing. -4. Am I done?
Nope.
No, that's only half the answer. Here's the question. If it was multiple choice, and you look down there at A, B, and C, and there's only one choice that has x equals -4, do you even have to do the rest? No, you could stop right there. Pick -4 and move on. Okay? Of course, you could work it out and check, right? But be smart about when it's multiple choice. Take -4 and plug it in right there, and I get 7 times -4 plus 4y is equal to -4. That's -28 plus 4y is equal to -4. 4y equals 24, I think. Y equals 6. So my answer is one solution at 4, 6.
-4.
Sorry. All right. Anybody have a question? You should have a question. There should be a burning question in your brain right now. I haven't shown you what to do.
What if it's not in order?
You're on the right track.
No solution or
You would just reorder it. That's not a big deal. But that's a good question.
No solution infinite.
Very good. Say it again loud.
No solution infinite.
How do we figure out what to do when I get no solution or infinitely many solutions? All right, and I'll show you. If your problem was set up as x plus y is equal to 4 and -x minus y is equal to negative 4, and you went to add them, you would end up with 0 equals 0. If you get an answer like 0 equals 0, which one of your, I've erased them, what do you think the answer is? That's a true statement. 0 does equal 0, so it's infinitely many solutions. Write that down. If you get a true statement, just like substitution, where 0 equals 0, then you can say infinitely many solutions. On the flip side, if you were to get 0 equals 2, then what would your answer be? No solution. So same thing. If you get a true statement, the answer is infinitely many. If you get a false statement, the answer is no solution. Questions? Message for Wilson. She needs to go straight to the auditorium by the side hall door to backstage to meet Savannah to take her picture when the bell rings to end third block. Okay. Let's do some practice over elimination. You might even type them in. Oh, though we already turned our remotes in.